Yeah, welcome to the US-RSE Virtual Workshop 2021. I'm Sandra Giesing. I'm on the steering committee of US-RSE and I'm a co-organizer with Julia Damaroff. And yeah, today and on Thursday, the theme will be a path forward for research software engineers. And we would like to thank all submitters and reviewers, the speakers today and on Thursday, and of course all the participants who are joining and still are joining, as I can see. So we are at 43 now. That is very exciting. Yeah, a little bit to the organization, we were really aware of that we wanted to plan it very early, that everyone has enough time for submission, preparing the slides, and then, as always, it got tight with coordinating it with some actions with the international RSE, and yeah, so we took it with us as a learning effect. Next year we start even earlier, and you can find the schedule of the meeting under this URL, but also a rough schedule is here. So we pause the intro and I will give them the word to Ian Carsten. Then we will have for 1 hour talks and a 50 minutes break, again 1 hour talks. And we gave the chance also still to submit breakouts for Thursday. So we have 4 breakout sessions on Thursday. So there were no further submissions. So it will be another break of 50 minutes and then we will have a social half hour. And the social half hour is PowerPoint karaoke, and we will add this tiny URL also in the chat. So we will go into breakout sessions and do some PowerPoint karaoke, but yeah, to prepare that a little bit, we will have also first a guinea pig before we start, then later when the social half hour is on, so that you can see what we have prepared. And I would like to remind everyone of the code of conduct so that we are, kind to each other and listen to each other. And you can read it on our website. And with this, I would like to give it to Ian.
So it would help if I'm unmuted. Thanks, Sandra. Let me share my slides. Can everybody see that? Good, great. Okay, so my name is Ian Cousin. On behalf of the steering committee, I'd like to give just a brief update, as we've been doing in some of these larger events, of what's been going on in terms of the US-RSE Association from an organizational perspective. Lots of exciting stuff's going on, and I know we get new members, so it's a brief update. Hopefully you're familiar with this, but just to remind everyone, what is it we're trying to do here? We have 3 main goals right now, looking at a 4th coming soon. You may have seen some communication about that, but building a community, running events like this, providing a place for RSEs and RSE allies and folks interested in being an RSE to connect, communicate, share things, advocating on behalf of RSEs, promoting RSEs, the work that they do, and finally providing some resources. In general, whether that's the individuals, the groups, to other constituencies that are involved in this space. So I don't want to talk about things that happened before 2020. We had an annual general meeting at the end of 2020. I gave a longer talk about what had led up to that point. It's available on our YouTube channel. If you're interested in some of the history and some of the events that has happened last year and the years before, you can go check that out. We had our first very successful steering committee elections. This year, what's been going on continued. Maybe this isn't new in 2021. We've been growing since 2019 pretty steadily. We continue to grow people from all over. We certainly don't limit this to the US, but as you can see, it's the vast majority of folks are in the US. We're not quite in all 50 states, but something we aspire to do. I've been running a number of events. This one, so we've been doing monthly community calls. If you're interested in seeing these, if you're new or you missed them, they are on YouTube. They are unlisted. It's really something we want to provide the folks internal to the community. So go on to Slack, scroll back in the community calls channel, and you can find a link to those there. We took a break this month. We'll be back on in a few weeks for June. You can vote on GitHub. All these were by popular demand. You can propose new topics. Really, this is what's interesting to the community. What do we want to talk about? A working group has spawned from one, and white paper is coming from the other. I've done some larger events. So in February, we teamed up with the Academic Data Science Alliance to do a career symposium. We had over 100 participants to come wanting to listen to hear about what data scientists and RSEs do. It's also on YouTube. As with the first series in this DEI speaker series, Dr. Sherry Pancake gave an excellent talk. Not necessarily RSE specific, it's broader. It's excellent. If you haven't seen it, I highly recommend it. It's also available on our YouTube channel. Hot off the presses, this just came to fruition, I guess, late last week or so. But US-RSE is now a member organization within the Open Collective Foundation, and this is going to provide us the ability to accept donations, to spend money, to essentially have a bank account, but transparently manage things as well. So more is coming soon. We'll hopefully, as we start to decide what it can do and what we're going to do, look for a blog post. But also on Thursday, if this is of interest to you, I'm having a breakout discussion as part of the workshop on some of the fiscal priorities are coming along, and direct all questions to Chris, is that I'm going to be serving as the treasurer. So as I mentioned, we have a few working groups, education and training, discussing things about what RSE training might need, what kind of resources can US-RSE provide, a roadmap, some aspirational goals towards things like a formal curriculum. All the discussions happening in the education and training channel to meets on a monthly basis. Go join the channel there to get more info. There's a website working group looking to redesign the website. It was designed a few years ago with a much smaller scope and organization in mind. There's a beta version if you're interested in design, content, things. Everyone's welcome. Go join the website channel over there. And the DI group. So this is the group that brought you the Dr. Sherry Pancake speaker series talk a few months ago. Next one coming up in June, likely. Date to be determined from National Center for Women in Information Technology. Book club. A little last minute to join a book club tomorrow, but keep an eye out for that thing. And as I mentioned, adding to the US-RSE mission, this important piece of DEI. What's coming down the pike? So Sandra alluded to this earlier. We're coordinating with the international community to have a day to raise awareness and advocate and show that this is in fact a global movement, this research software engineer idea. That mark your calendars, it's set for October 14th later this year. More information to come. If you're in the HPC world, there'll be a workshop at SC21. If you have an idea of where maybe people would be interested in learning more about either US-RSE or research software engineers in general, certainly reach out. We're happy. We don't mind bringing this show on the road to talk. We'll be continuing to do the monthly community calls, and of course, the goal here is to have community engagement. So encouraging and supporting the working groups, and if there's special interest groups that evolve, and encouraging community interaction. So you might have seen this before. Pretty much everything's happening in Slack. We get these questions a lot, and I want to reiterate it. Can you post? Yes. Can you create a channel in Slack? Yes. Can you start an initiative? Yes. Can you organize an activity or event? Yes. Is it only for HPC National Labs Universities? No. I mean, really, we want to be open and encourage really anyone. If you have a special interest, if there's something there you want to connect with, post something in Slack and see who you can get. So with that, I want to end. I feel I need to make formal recognition to Sandra and Yulia for all the hard work that they've done in putting this together. And anyone who's done something like this knows it's a ton of work. They pulled it together. You know, it's been really good. So a virtual round of applause to Sandra and Yulia, but also everyone who took time to submit talks, the reviewers, the presenters, and everyone who's here. So thank you, and looking forward to a great workshop. And back to you, Sandra.
Thank you very much, Lee. And we have the first question, I think. So, Jonathan.
I should have mentioned, if there are questions about this in general, Slack, chat, while these talks are going, I'm happy to answer more. I know I used up my 5 minutes and more.
Oh, Jonathan, was that a raising hand or applause. Maybe
applause for you, Sandra.
Oh my gosh. Okay. I thought there's a question. Thank you. Thank you. So yeah, it's my pleasure to introduce the next speaker. And of course, since we made you all sending us a sentence, I will of course introduce him with the sentence he sent us. And so Reed Milovich, and I hope I said the last name the right way, and he's from Sandia National Laboratories. And Reed is a senior scientist and artist in residence at Sandia National Labs. His hobbies include weightlifting, amateur graphic design, and learning French. So,
right.
And one of his co-authors sent also his information, and I think it's nice to, so he's not the primary presenter, but he wanted to let us know, so James Willenbrink from also Sandia National Labs, that he is a swim dad. So now, Reed, you can take it.
All right, thank you. So I'm aiming for about 12 minutes. If I go over, let me know. I'll have time for questions at the end, so if you save those towards the end. Okay, so let's go ahead and get started. So good morning, everyone. My name is Reed Milovich. As Sandra said, I'm a senior member of technical staff in the Department of Software Engineering and Research at Sandia National Laboratories, and I am excited to kick off this workshop with a talk about our work at Sandia to build career pathways for RSEs. So today I will introduce our RSE group, that is the Department of Software Engineering and Research at Sandia National Labs. I will describe our organizational strategy. That's what we call a research, develop, and deploy model, which integrates RSEs into a cross-cutting interdisciplinary team. And then finally, I will offer a reflection on our experiences and why we feel that this approach to teaming is helping us to do our best work. So to start, what do we know? So we know now that software is critical to the practice of science. We are experiencing a paradigm shift towards a future of science that is equal parts theoretical, experimental, and computational. And with that, we've seen a dramatic growth in demand for scientific computing. Meanwhile, we also know that we need professionals who can advance software engineering practice in the scientific domain, namely RSEs. Realizing sustainable, high-quality software demands more specialized skill sets, more diverse perspectives. RSEs are part of that equation, and they're instrumental to meeting that demand. And finally, we know that to meet these workforce requirements, we need organizational structures that give recognition to software-focused personnel and provide pathways for career advancement. So on the institutional front, there are many research organizations that have made strides towards creating positions and groups for RSEs. Within the Center for Computing Research at Sandia, the recently formed Department of Software Engineering and Research is filling that role. So let me tell you a little bit about ourselves. So our department formed in late 2018. It was the culmination of several years of effort to network RSEs across our center, who were previously split up across many different departments and projects, to bring them under one roof. And as an RSE team, our department provides flexible on-demand staffing for development, consultation, and support to other departments within the Center for Computing Research. Our goal, in our work is to advance the study and the practice of software engineering in the scientific domain. So we want to bring software engineering expertise to the labs, but more than that, we also want to be innovators, people who are pioneering new and better ways of working with and thinking about research software. But what does that mean exactly? So I want to give you kind of our philosophy, how we look at things. So one, the term RSE encompasses a diverse range of people, all of whom regularly use expertise in programming to advance research. Of the 20-ish people on our team, the majority of them are RSEs. However, there are also computing professionals who may not consider themselves RSEs, but who share a common interest in scientific computing. This includes software engineering researchers, DevOps practitioners, and IT service management specialists. And those folks are part of our team as well. And our belief is that by integrating RSEs into a cross-cutting team, alongside fellow computing professionals, is what enables us to be more cohesive and creative and productive overall. And this belief is reflected in what we consider our organizational model, which I'd like to explain. So our team structure is centered around three principal workflows. That is research, development, and deployment, or RDD. So each staff member primarily specializes in one of the three, though they participate in all of them to some extent. Each leg of the triangle is meant to provide capabilities that reinforce and enable the other two. So I'm going to walk through those three and explain how they fit together. So research, that's in my wheelhouse. Software engineering research, or software science, is the study of software systems and their development, their operation, and their maintenance. Take me as an example. So I have a PhD in computer science with a focus on software engineering. I study scientific software development so we can figure out better software engineering practices and processes and tools. And as a team, we engage with research so we can bring innovative ideas back to the labs. We try to promote evidence-based practice on our team, and we hope to better understand how best to serve our customers through research. The second part, of course, is development. Many folks on our team work directly with scientific application and algorithm researchers to provide embedded development and maintenance and support. And this describes the primary role of our RSEs. So we combine a knowledge of like HPC architectures and domain algorithms with software engineering best practices to enable our center scientists and mathematicians to do their groundbreaking work. Finally, we have deployment. So we find that having robust, scalable, and sustainable infrastructure is really key to our mission. So what we do is our team provides and maintains all kinds of foundational infrastructure for our center. This would include dependency management tools, build and test farms, team collaboration tools like Jira and Confluence, automated support tools for GitHub, and an online help desk. Team members who focus on the deployment work primarily, those are people who tend to have a background in DevOps and ITSM. So all of these components are meant to be mutually reinforcing, right? And we view this as a force multiplication strategy. So that is, we're able to do more together, as one department, as one team, than if we all just work separately. So on the research side, of which I'm a part, we provide consultation and support both within our department and to customer teams. So that way we can develop innovative capabilities, help meet needs. Then as a researcher myself, having embedded developers that I can work with, RSEs, that's critical to me to know what's happening on the front lines. Developers also work with our deployment staff so we can match customers with resources. And then finally, our deployment staff help make our development projects orders of magnitude more efficient, because they have access to all these tools and infrastructure that enable them to do their best work. And they also provide, for me, an ample source of data across all our different thrusts, which is beneficial for research. So for our RSEs, the result of this organizational strategy is that whenever they're assigned to a project, even if they're the only person, the only RSE embedded with that scientific software project, they're never going alone. So as a researcher, I'm on hand to help overcome any challenges they face in their work. My DevOps and ITSM colleagues provide work tracking tools, CI/CD infrastructure, and help desk support. And then all of our RSEs are part of the same team, and that way they're able to reach out to one another for guidance, help build a community of practice. So in conclusion, at Sandia National Labs, the Software Engineering and Research Department is seeking to provide sustainable career pathways for research software engineers. We believe that, at least in our context, having an interdisciplinary strategy works well. It's a strategy in which RSEs are integrated into a team alongside other specialists from other computing disciplines, and we're able to work together to be more productive, and that enables RSEs to continue to grow in their careers. And now, I don't want to claim that we have the definitive answer for how to structure an RSE team. We are hoping that our experiences could contribute to the broader discussion around this topic at this workshop. And I'm proud to say that our team has several talks at this workshop. My colleagues will be happy to tell you more about the specifics of our products and services, but I am happy to address any questions you may have now. There you go.
Thank you very much, Reed.
Of course.
So yeah, questions. You can put something in the chat, or you can raise a hand. I look now through all the pictures.
Yes, and my manager is also on the line right here, so she might be able to answer some of the specifics better on the funding. It's fun. There's a mix of different funding sources. So we have a lot of project-specific funding that we get. There are also other external funding streams, like I'm part of the Exascale Computing Project. We have several people that are on that, and they're getting funding to do like multi-lab ECP work. So there's a diverse mix of funding. But I think majority by weight would be we embed with different research teams in order to help them do their development and support them in their work. And there's a lot of funding that comes through that. There's also like center funding that we have for like our maintenance and support work, help desk, stuff. Are team members ever embedded in multiple projects at a time? Yes. And yes, this is a challenge with all matrix managed organizations, right? Where we want to be able to flexibly split people across different efforts, but it's still sort of an evolving issue where we're trying to figure out how best to like align our team with all the different demands, because there's a lot of demand for software engineering expertise at the labs. Joffrey also says, we also had centralized RSEs, although that makes them stronger. It creates a communication and cultural barrier to research. How do you bridge that gap? Well, I would say that when we started, I would not have described us as a team, right? Because we were still learning and growing. We have, and Derek will talk about this today in the first session, we have a number of strategies that we use in order to try to build us up as a team and speak a common language and the like, including like, best practices meetings. We kind of get together, we talk about like software engineering stuff, right? We frequently have get-togethers and potlucks and other events. And over time, I think we've kind of come to a common understanding about all our different specialities and how we fit together. Takes time though.
So yeah, we made, for example, at Notre Dame the experience that it also helped to have computational scientists. So one of my roles, for example, is a computational scientist, so between the research software engineers and the researchers, and I have my own research. So that is the model that you thought about, or that is not?
I don't think we know. We have some people that as RSEs who transitioned, who had a background in mathematics or a domain science, right? Though I think we're more on the software engineering end of the spectrum, right? But it is a value add, I would agree. Like being able to speak the same language as the domain researchers. So when Joffrey was just asking that question, when I was thinking of research, I was thinking in terms of my research, right? I'm a computer science PhD, I'm a software engineering researcher, right? And there are ways that we have that, kind of bridging that gap, but there's also the gap between us and the rest of the lab and the rest of the center, all the domain scientists and mathematicians. And that really does take time. I mean, there's no easy answer. I mean, learning each other's language, right? But we do offer training to people, to the center. We try to promote our products and services, explain how we can offer value and kind of bridge that gap.
Yeah. So Keith had his hand up. Keith, would you like to ask your question?
Yeah, I'm curious to hear about the transition. You mentioned that this started as an earlier effort and the transition to the formation of your department and group, specifically about how you dealt with pulling people from different parts of your lab together. We're facing the same thing, and I'm trying to do the same thing, but I'm a little bit worried about people feeling possessive about, the one lone little software engineer that they hired.
We actually wrote a white paper about this, and I will share that white paper with you. So I have materials on hand. The thing is that it took place over many years. We had the Software Engineering Maintenance and Support Effort, or SIMS, right, that preceded the formation of the department. So it was a network of different, software engineering professionals across the center, because before we were all scattered among many different departments, many different teams, and no one else really spoke our language. We spoke our own language, right? We had these skill sets and these perspectives. And in that sense, it was a little, I think Dina might be able to add to this, but I think it was a little bit easier for us to bridge, to get together simply because of our shared background and heritage, right? But I wasn't around for most of that.
Okay, it sounds like a necessary first step to build that community.
Yes, but but having a department makes it so much easier for hiring and for support and for allocating funding. So having official organization to say we are this RSE team, we aren't just like some informal network, but we are a part of the institution is really key, I think, to advancing the careers of RSEs.
And this is Dina. I'm the manager of the Software Engineering and Research Department. This really was, as Reed mentioned, it was a longer term kind of effort. And I would have to say that without organizational support from our managers and leadership, this would not have happened. We needed not just the people who comprise the software engineering and research, but we needed organizational maybe advocacy for a department and the understanding at a managerial level that what we were doing was adding value and impact. So it really was kind of a combination of Sem's being very impactful. I will give Mike Haru credit in that he added to the conversation with advocating research as a first-class citizen component of this effort. And then our managers, just really buying into this and wanting us to succeed.
Great.
Yeah.
Thank you very much.
Yeah, and I think we have like 2 minutes till the next. If anyone has another last question, maybe.
So I don't see another question and no hand raised. Please interrupt me if I overlooked a hand.
And I'll be on all day, so if you have any questions for me.
So thank you very much, Reed.
No problem.
It's my pleasure to introduce the next speaker, Jonathan Darcy.
Hello.
And, hello, and of course I will look for your introductory sentence. So he's from the data team, the University Health Network Toronto in Canada, and his introduction is that he has watched research computing teams succeed and struggle from astrophysics to genomics and beyond. And he will talk about help, I'm a research software manager. And he did a recording of his talk first, but he's around for questions and everything. So Jonathan, try maybe to share and show your video.
Yeah, absolutely. So, hi everyone. So I've got a recorded video so I can answer questions in the chat. I just want to say it's great to talk about these bigger picture things, like how do you structure a research software team? How do you manage one once one exists? These are really important, I think, next steps in the progression of research software engineering. So I'm going to start the video and I'll be around during chat, and of course I'll be around after the video. One second. So hi and congratulations. Whether you're experienced, new, or even just thinking of becoming a research manager, it's an important job because research software is important. And as a community, we've come a really long way in the last while about professionalizing the craft of the individual research developer. That's incredibly important. And to get to the next step, we need to professionalize the management of research software teams. So I'm really pleased to see so many talks that touch on this topic today. The thing is, nobody tells you this, but becoming a manager, it's not a promotion, it's a career change. You've gone from probably a very experienced coder to a very junior manager, and no one tells us how to do this stuff. It's just different work that requires a different set of skills. Kind of famously, academia does not teach us this. You've probably had very few good examples. So it's easy to feel kind of lost in that sea. But the thing is, great management isn't mysterious. It's not about your personality type, and it's not even particularly complex or hard. It is about learning and applying a new set of skills and practices. And we're pretty good at learning new skills. It's known what good managers do. And the thing is, I'm going to argue today, you're probably already doing a lot of the hardest parts. Why would I say that? Well, let's talk about Google for a second. So like a lot of Silicon Valley companies in the mid-2000s, Google was pretty skeptical about management. So in 2009, they commissioned a study, Project Oxygen, across all of Google. Do managers matter? And yeah, it turns out they do. And the data was convincing enough that Google in 2012 started changing how management was done across the company. It knew what it wanted to see from managers. It developed new management training, and that stuff's available online. Crucially, what Google found wasn't new. They rediscovered things that have been known for decades. But Google's work's been very influential in computing, and I think it's a really good lens for us in research software, because they came up with a list of things great managers do, sort of advanced skills, and sort of basic skills, things that if they were absent in a manager, they ended up being a pretty important shortcoming. And I think that if you've been in research and research software for a little while, you probably have built up some of those advanced skills because research software is intrinsically collaborative, and collaboration is hard. So if you've sort of been involved in a research collaboration project before, you've probably done things like learning underlying needs from the researchers, getting agreement on objectives, make sure everyone's working successfully on their own part, make sure grad students and postdocs develop their skills. Most research software teams I've seen are very generous about that. And then, execute and get the software done and papers out. These line up really well with a lot of the advanced skills. We just need to avoid the pitfalls by learning the basics. And the pitfalls Google kept seeing were having trouble making a transition to manager, lacking a consistent approach to performance management, spending too little time managing and communicating. Okay, great. So how do we do that? So there's 4 things you can start doing to be well on the way to being a great manager. These are well understood, time-tested management techniques. There's one you can start now, which is having one-on-ones weekly with each of your team members. 2, you could start pretty soon, giving frequent specific feedback, positive and negative, to your team members, and judiciously and increasingly delegating responsibility. And 1 sort of ongoing, understanding that you're not a software developer yourself. These directly address the pitfalls Google kept seeing. So let me start with what's maybe the easiest, weekly one-on-ones. This is really, really simple. Every week, I've scheduled 30-minute one-on-one meetings with each of your team members. This isn't about status report. You can get that from the Jira tickets or whatever. It's about working with them, about learning what they need. It's their meeting. I like the manager tools agenda for this. There's some links at the end of the slide. 10 minutes. They go first always, whatever they want to talk about. 10 minutes. Their career development, the skills they want to develop. This is pretty uncommon in academia, but it's super common elsewhere. There's lots of resources out there if you want to learn how to do them well, but honestly, it's not that tough. You show they have your undivided attention by things like always having the meetings and taking notes. You learn about your team members. You learn the things they need from you. You let them know they'll get them, and then you build trust by following through. Every so often you review the notes. That's really all there is. This is easily the most valuable time you spend as a manager. By doing this, you'll understand your team members better, understand what's going on a lot better, and you'll show you care and you build trust. And kind of for your own benefit, after you start doing these for a few months, you're going to start feeling like you kind of have a grip on the whole management. Next up is giving frequent and specific feedback. Developers deserve to know what they're doing well and what they should change, and they deserve to know that as early as possible. And they feel more productive when they're getting useful feedback. There's tons of research on what works, and it's, again, not super complicated. Feedback should be prompt, it should be super specific so they know what to do, and it should focus on concrete behaviors demonstrated and their impact. So rework Google's thing focuses on one model. There's others, situation, behavior, impact. This is a way of making a little formula for yourself so you know how to construct the feedback. So like, nice job on the presentation is a heartwarming thing to hear, but it doesn't really tell you anything you can do anything. Much better is, in today's presentation, you covered the background material very clearly. It really helped Professor X's group understand what we need to do. Or rather than you need to be better at doing code reviews, on the PR for the updated model, it took a week for you to do the review. That blocked Mayeli's progress for half the sprint. So None of this is about blame or praise. It's about clarity of expectation and nudging people towards those expectations in the future. Your team members deserve to know what the expectations are, and they deserve to know whether they're meeting them. Most of your feedback should be positive. That's just it means taking the time to call out specific things they're doing that help you or the team that you might just not be mentioning. And having these frequent, small, early feedback conversations prevents a lot of big, stressful conversations down the road. Next up, delegation. This is really just a matter of keeping an eye out for matches between tasks of yours you already know how to do and team members for whom the task might be a bit of a welcome stretch. Then you tell them why you think this would be a good match for them and ask if they'd be willing to do it. And if so, give them the support they need as they learn. Doing this helps your team members grow their skills and gives you room to grow and tackle new challenges. Doing this well requires knowledge of your team members and their career goals, which comes from one-on-ones, and the ability to give them guidance, and that comes from specific feedback. Finally, acceptance. The job now is to make your team more effective, not to write code yourself. You're no longer a maker, you're a multiplier of their work. That means a lot of glue work. It means helping your team members advance their skills and career. It's a lot easier to let go of coding tasks when you know what management tasks look like. And hopefully some of the talks today will help with that. So mastering new techniques is always hard, and starting some of these practices might be uncomfortable. But you've learned harder skills than these, and you felt awkward or clumsy until you mastered them. And you did it anyway, because they were necessary for what you wanted to accomplish. So the formula here is pretty straightforward. Start one-on-ones in the coming month, give you time to prepare, and then the following couple months, learn about giving specific feedback and start. As you get to know your team members' career goals better, start using targeted delegation. And if you're doing most of these things in 6 months, you're doing great. There's lots of resources out there to help. Research deserves the best support research software can offer, and you can be the manager your team and research needs to deliver that support. Thanks very much, everybody. Hey there. So that's the video. That'll be available somewhere else, and I've got links to resources that I and others have found useful if we want to go over those. I'm happy to answer any questions.
Okay, we have some questions in the chat. Let me go back where they start. So, Rich, do you want to maybe speak about your own question? Unmute yourself.
Sorry, I just took a bite of a sandwich.
Sorry.
Let me clear my mouth. Yeah, I mean, I've been on both sides of it. I've had up to teams of, my biggest team was 80 people, 80. And trying to do, let's say 30 one-on-ones, 30-minute one-on-ones with 80 people in a week is really challenging. So I could not do that and get anything else done. So that was something that had to be spread out a bit more, and they worked across different shifts and different parts of the globe. So it was just a little bit longer. But the thing that I've seen, and I am coming at this a little bit differently because I've spent 25 years in the corporate space, worked for small companies and big companies like Cisco Systems for 10 years. And that's my experience, is that new managers are typically taken from the best of the team that they are on, whether it's sales, whether it's customer service, whether it's IT or whatever. It's like, wow, you're the best. So that means that you're going to be the best to lead this team. And that is not the truth, at least not initially, in my experience. Again, I think Jonathan really encapsulated it well. It's not rocket science, but there does need to be a transition period where you learn how to detach from the thing that you were great at to become the people manager that people need. And it's not just about approving PTO or, you know, whatever. There's a lot of things that you need to do in studying human performance and career development. There's just so many things, you know, you want to retain your talent. Those are all things that managers have to contend with. And I don't think that, like Jonathan said, I don't think that academia prepares people well for those kind of operational requirements. So more of a statement, I guess, than a question, but great stuff, Jonathan.
Thanks, Rich. Jonathan, you want to comment? Otherwise, I would go to the next question.
Yeah, sure. No, I think Rich identifies, yeah, a real problem. And I don't have much to say other than to agree.
Great. So Reed, you want to?
Yeah. My question here is, what's your advice for managers with more of a software engineering background, this RSE spectrum, having to interface on customers with research teams? How do you bridge the divide between languages and cultures so you can provide what they really need?
Yeah, it's really tough. And I think as you sort of gain more responsibility, this is a real problem, because you start gaining responsibility over interactions in areas you've never had expertise. I think if there's particular specialties, you as a manager can sometimes learn that particular language going to talks or the like. But if there's lots of different communities, you just can't. There's so much you can shove in your head. So at that point, I think either bringing team members of your own along to the meetings who can bridge that divide, or just really digging into the problem and making the researchers really spell it out. Either of those can work. But yeah, this is sort of almost the same thing as or related to what Rich was saying. At some point, you just have to let go of the fact that you know everything and can do everything yourself, and you just have to sort of mitigate those gaps as best you can. Sorry, Reed, that's not really much of an answer, I know.
No, I thought I'd try, see if you had any insight.
So we have a couple of more questions. I would give now the word to James about the feedback, and then we might have, because of timing, to answer it maybe in the chat and go to the next talk. But James, I would give you the word.
So, right, I was just wondering with RSEs how you get the feedback and ensure that it's the science teams that are happy, as opposed to just how happy your manager is with you. Because as the role of the organization, it's really getting the science done and making sure that those interactions are working that's important.
Yeah, and Reed pointed out the challenges, these matrix environments. I mean, it has to be the manager's job to one way or the other be making sure that the researchers are happy. That can come through the software developer. It can be check-ins with the stakeholders. But yeah, if the manager isn't super clear on what the goals are and how to know if they're being met, then the poor research software engineer just doesn't stand a chance, right? So it's on us as managers to know what's going on, know that the stakeholders are happy, and to make the expectations really clear to the team members.
Thank you so much, Jonathan. Keith, can you put your question also in the chat, maybe to discuss it with Jonathan in the chat? Is that okay?
That's fine. I'll do that. Thank you.
Thank you very much. Thank you, both speakers, for excellent talks. And we go to the next speaker. So the next talk will be about towards a culture of continuous improvement within RSE teams, and also from Sanyo National Labs again. And speaker is Trembo. Derek, can you share your screen?
Hi, yeah.
And during that, I hope I didn't miss your email about it, but I think we didn't get an email for your short introduction.
Oh yeah, right. I'm sorry, I missed that. I didn't.
Oh no, I will punish you for that now. So, so only for all the participants, we asked each speaker to give us a short introduction, like a Twitter short introduction we could say before the talk to have a little bit more, instead of just reading the name or the title. And since Derek missed out on his chance to introduce himself, I introduce him as one of the speakers in the social hours who will give a talk on, and he's very enthusiastic about cats. No, you don't have to, but only the thing that what I could have done, you know?
I like cats, nothing wrong with cats.
No, I give the word to you. Take it.
Awesome. Just a quick check. Am I sharing my screen okay here?
Yeah.
Looks good.
Okay, cool. My name is Derek Trembo. I do like both cats and dogs. I'm a principal member of technical staff at Sandia National Laboratories. I am in the research, software engineering and research department that has been mentioned already today. And Reed also, who's helped me with this talk, has been already introduced today. So I'm going to talk about towards a culture of continuous development within RSE teams. So for today's talk, first I'm going to define and make the case for continuous learning and improvement, provide an experience report on a couple of activities within a few of the teams that I'm on at Sandia, and then discuss some of the impact and lessons learned. Now, I'm going to be speaking kind of from the perspective of how one manages a software team. This perspective is very much in line with the perspective of a team lead or other team leadership role, but really any team member can and should advocate for practices that make themselves and their fellow team members and the team as a whole more knowledgeable, efficient, and effective. Okay, so the research software at Sandia is very large in scope and complexity. It contains many different technologies, programming languages, patterns, and architectures, and it's constantly evolving in new ways. And so as RSEs, we have to stay current with tools and best practices and always be looking for a better way to design, develop, and maintain software. And so the question really is, how do we build and promote long-term growth? So I'm going to go ahead and take basically attempt to put a little definition to this phrase, continuous learning and improvement. To me, it's a set of sustained mindsets, behaviors, and activities that gradually lead to better team members, better teams, and better products over time. And so continuous learning can, in my mind, be divided into a couple of categories of what is actually required. And I think that the first one is an admission that there's always room for improvement, that no team member is perfect, no team is perfect, no product is perfect. Once we think something is perfect, it kind of just falls to the back of our mindset, and we might let things slip over time. We could get blindsided in the future if we don't think that there's always room for improvement. It's all just comes down to prioritizing. What do we do about that? And that's the second part, commitment. It requires a desired commitment to effect improvements. So we can't just admit that there's room for improvement. We have to say, okay, well, then what are we going to do about it? And that we can have a culture of striving for excellence, integrating these principles into the team culture so that everybody is aware of it, and keeping each other accountable for this desire to improve. So to that end, though, there's a couple of principles that we could discuss with these categories, and a lot of this speaks to team culture, and positive team culture is another thing that I'm passionate about. So when in the admission side of things, it takes a lot of humility, it takes honesty, forgiveness, self-reflection, a willingness to give constructive feedback, and also receive feedback for your own work. And commitment takes determination, focus, curiosity, and a desire, again, for excellence. Now, change doesn't always happen overnight. Somebody might, turn on, get your code converted over to a CI/CD pipeline, and all of a sudden you have all these great benefits overnight. But on the whole, the total quality of your products, it doesn't happen overnight. It does take patience and perseverance. And all team members must feel responsible for and invested in that effort. And that's where the team culture comes in. When new team members come on the team, you really have to set, be kind of clear about what your team culture is. What are your principles that your team, lives by and does their work by? Because the more you instill that into each of the members, the easier it all is, because you're all on the same page. So what actually can be improved? So what are some of these areas of improvement that we're talking about? So knowledge, skills, and abilities, obviously, how effectively we can do our jobs. Productivity, this is a very important topic. And not trying to say that we should make people work more, but within whatever time frame that people are working, have that time spent while they're working be as efficient as possible. And to do that, there needs to be resources available to them, and training, etc. Decision making, obviously, when people making good decisions we don't have to go back on, that kind of make us spend extra time than we need to. Empowering but not requiring independence. The more independent that our team members are, it just less points of contact that need to be made and less bottlenecks, etc. But to that end, an area of improvement, of course, is teamwork. And this can be thought of as the ease with which team members can share information, remove each other's roadblocks, coordinate their work with each other. And morale. So a lot of the above factors rely on the excitement of the team to do their work. And so, and practices that demonstrate investment in team members and their careers will obviously lead to happier team members. I think all this boils down to a couple of broader categories. There's customer happiness and team happiness. So customer happiness is the classic, quality, schedule, and cost. Those are the three things that really matter to the customer. And team happiness is, do team members want to keep doing what they're doing? So I'm going to describe a couple of teams and some experiences on those teams. First, we have Tech Talks within the Avondale program. And the Avondale program provides web crawling and text analytics services to inform and accelerate human decision making. Now, in this team, all team members are working towards like a common mission objectives, kind of like a traditional, okay, I've got a team of people, they're all building a product. And also the best practices meeting within the Department of Software Engineering and Research. This is a multidisciplinary group that has been described already today. And these team members work on a variety of different mission programs, all with their different facets, but together, we're still together, for the goal of centralizing this great best practices and body of knowledge that we have. So Tech Talks are deep technical dives into specific technologies or libraries, architectures, practices that team members are faced with their day-to-day duties. So we want to enhance the team members' abilities to be effective within that team, and also enhance team members' skill sets for long-term career goals. It's always a little heart-wrenching to think of your team members leaving your team as they become part of your family, but you got to kind of think a little bit further out and say, well, we want what's best for the team, but we also have to think about what's best for each individual person. So it's just the way it has to be. These are held at regular cadence, at least 2 to 6 weeks, as long as you find topics. 90 minutes is a good kind of like, solid, like here is a good amount of content, though they don't have to be that long, of course. And presenters could and should be anybody on the team. And so this is a very strong stance of inclusivity, make sure everybody at any level can contribute. Sometimes even if it's a junior member, whatever task they're on, they might be very inexperienced and new, but they might just give them a chance to describe the work that they have been put on. And that can have a huge boost on morale. And presenters can be volunteer and team leads, and also ask people to present. So what are some example topics? IDE proficiency, group programming challenges. I wrote software to guide a whole group to look at the screen and go through code examples together to talk about what's wrong or what are the mistakes in this code. Somebody might give an intro to graphics, tokenizing text, getting people up to speed on the command line. You might have, describing, a team process in depth, multi-threading tutorials. This is a big one, of course. There might be subsystems and subsections of the software that need to be described to the team. And of course, third-party library tutorials. The best practices meetings are weekly roundtable discussions where we join together to deliberate, discuss processes and principles that lead to high quality software. So the goals here are just slightly more, less kind of inward, because you can see the makeup of the two teams are different. The goals here are similar, but a little more outward focus, increase the awareness of industry best practices in the team so that they can then go on to their own mission teams and be effective, but also spread awareness of best practices within the sphere of influence of the team, our sister groups and within the community at Sandia. Also held up to 90 minutes, and be anyone on the team, or in this case, speakers can be invited from other parts of Sandia. We've actually had people outside of Sandia as well. And so just some example topics: clean code video series, test-driven development, software requirements, customer support principles, solid principles, CI/CD pipeline tools, building good team wikis, code review practices, and research and software engineering. So as you can see, these topics are just a little bit different slant on it because we're talking about many teams now that this best practices meeting could be addressing. Some of the lessons we've learned: team members look forward to these activities, are engaged with proposing new topics, and felt like they were learning and growing. And so dedicating time to these activities have helped our RSEs grow as individuals, promoted a community of practice and made our teams more cohesive, and enabled us to retain cutting edge and software engineering on the cutting edge of software engineering, so we can continue to deliver high quality software. So just to wrap it up, we've discussed the need for continuous learning, improvement on RSE teams, explored the impact that these activities had, and we hope this helps other teams at other institutions implement similar activities. This wasn't necessarily, this was mainly to provide kind of blueprints and templates for what you could do at your organization, not necessarily saying that these exact templates are what you would implement, but just kind of showing some high level templates for that. So thank you very much.
Thank you very much, Derek. Great talk. So I don't see a question in the chat at the moment, and also I see clapping, but not a hands up. So clapping is also good. Let me see. So here's one question. And of course, so Rich, would you like to discuss that for a moment?
Sure.
Sorry. Okay, go ahead. Yeah, go ahead.
Sorry, I'll turn on my camera too. So what I'm trying to get at here is that the diversity of organizational structure also seems to be a huge contributor to the chaos of managing software integrity over time. And so I'm kind of wondering if you have any thoughts about how to how to centralize that effort when you're not necessarily a centralized organization, in terms of like where all the RCs sit under like research computing as a group.
Yeah.
I just
So
saw Brandon
yeah.
talk about that. So anyway, because I see it as like, you know, grad students work on something for a couple of years, then they graduate and that code just sits there, you know, for forever, and doesn't get touched on. But anyway, so I don't know if we need to delve into it. I don't want to steal Miranda's thunder, but that seems to be, you know, kind of a.
Derek, you can absolutely allow, you can totally steal my thunder on this one. If you want to answer anything, I'm fine with it.
Yeah, so I don't think that I'm not exactly sure. I'll be honest, I'm not exactly sure if I understand the question quite clearly yet. I might actually just punt on it to actually let Miranda maybe address it. If I'm just being honest, and I know we're kind of crunched for time.
I think because we're pressed for time, maybe Rick, if you are able to, or Richard, if you're able to come on Thursday and listen to my talk, then maybe that'll help kind of answer your question a little bit then.
Yeah, no problem.
Great.
We'll park
Thanks.
it.
Yeah. Yeah. So I haven't seen another urgent question at the moment. So thank you again, Derek. And because of time, we would go to the next speaker. And I would have another question, whether it's okay for everyone that we are taking a group picture. I know the typical group picture at face-to-face is a little bit different, but we would like to have a group picture of this group after the next talk. So if everyone could stay on a little bit in the break, that we can take screenshots of participants, that would be great. Of the screenshots of the Zoom call. So, okay, so we're going to the next speaker. And our next speaker is Vanessa Sochart. And she talks about collaborative container modules with Singularity Registry, HPC. And she's from Lawrence Livermore National Lab. And her introduction is that she's a Vanessa Saurus. And Vanessa, you want to show your video yourself? Okay.
Cool. Yeah. So my talk is actually recorded also in advance. I thought that'd be fun to try it. So I'm going to start playing it. And if you guys can't hear something because Zoom is buggy, just like scream and wave your arms and we'll try to fix it. So does that sound like a plan? Yep. Okay. So let's go.
Oh, great. So I don't hear the sound.
Okay, let's try this again.
You...
Hi everyone, do you hear it now? I'm Vanessa Sochart. I'm a computer scientist at the Livermore National Lab.
Yep.
And today I want to talk about collaboration and working together. And I want to present this in two ways. First, with software that I'm working on called Singularity Registry HPC, collaborative modules. But then I want to get a little meta and kind of think about how we work together.
Vanessa, can you increase the...
Did you check the box to optimize sound and video?
What'd you say?
There's 2 check boxes at the bottom of the share window.
Yeah.
And if you don't check it, then we're hearing your speakers, not the actual audio.
Oh.
So stop sharing and then reshare.
Oh, share computer sound.
Yep.
Yeah?
That's the one.
Okay. Should I start over?
Yes, please. Yes, please. Yep.
Okay. Tell me if this sounds okay. Hi, everyone. I'm Vanessa Sochart. I'm a computer scientist at Lawrence Livermore National Lab. And today I want to talk about collaboration and working together. And I want to present this in two ways. First, with software that I'm working on called Singularity Registry HPC, collaborative container modules. But then I want to get a little meta and kind of think about how we work together. So I want to propose to you today that there is this high-level formula for collaboration that we all kind of know about and we do without thinking about it. And it really starts with identifying an actual need or a problem that crosses communities that will inspire collaboration. So with that in mind, let me present you with a problem. As you know, when we use high performance computing systems, we have this need to install software. And as containers have become more popular, that need has sort of transitioned to wanting to provide containers to users. And so what you're looking at here is documentation from UVA Research Computing. And you see that they had this problem. They wanted to provide containers to their users. They tried Singularity Library. It didn't have enough space. So they said, okay, let's make a Docker Hub organization. Here is how you pull the container, best practices, etc. Of course, using these traditional registries like Docker Hub and Quake.io, it's kind of problematic because they weren't really designed with the HPC use case in mind. You know, imagine every user is pulling their own set of containers. That's a ton of redundancy. Users are probably not thinking about best practices, meaning they're probably pulling a latest tag, which is a moving target. They're also probably pulling the same container at the same time to like 10,000 nodes, which is neither good for the cluster or the registry. And so while it's not impossible to be reproducible, it's kind of really hard. It's very challenging. So ideally, what if we had a registry that was sort of native to HPC? So an admin could install and provide containers for their users, or users could also roll their own, maybe just for their lab or something like that. And what if it was done in a way to encourage reproducibility and make it easy? So back to our formula for collaboration. So the next step is we have to find an idea that fits into the way that people currently think and their current practices, because asking someone to like learn something new or do something totally new, it's just not really going to happen. So I thought about this, and it's like, you know, there's sort of this bread and butter way that we provide software to users on HPC clusters, and that is with environment modules. So could we provide containers as modules? And in fact, you're probably saying, Vanessa, that is not a new idea, and you are correct. So I did a little digging, and here's an example of software called Community Collections, which had in mind to be provided to an admin. An admin would write a bunch of recipes and then build them and then install them for use by the user. When I looked a little closer though, so here we're looking at the configuration file, I found some things that I thought were problematic. So while it might be great for you know, an admin to be able to maintain one file, this would make it very challenging for sharing your recipes because everyone's configuration file is going to be like a special snowflake. Also, if you look here, you'll notice that it's sort of limited in how you can define interactions with containers and even the calls to them. And also for versions, it's a range of versions. You can't say like, I want this exact tag and this exact digest. So overall, I thought it was not really easy to collaborate on, not totally modular enough, and not enough granularity in being able to sort of define these interactions. So with these things in mind, I could then start to put together my plan for my idea that would fit into current practices that would solve this problem. My first goal was reproducibility. I wanted it to be possible to find exact tags and digests. The next thing is I wanted it to be easy to use. So maybe clone a repository, pip install, and then be done. And then to some degree, I wanted a little bit of abstraction. So interactions with containers can be complicated, like container software, do this thing, bind all these things, all these other options. And I wanted the user interacting with the module to just feel like they're interacting with an actual binary. And finally, I wanted automation. So once a container recipe is added to this registry, I don't want to have to manually update anything. I want this just to happen automatically. So I built a thing, and let's talk about how it works. Well, installation is easy. You git clone, you cd, you pip install, and then this executable shpc is available for you. Now you probably next want to install some containers. So you could use the command line tool to look at what's available in the registry, but there's also a nice web interface where you can browse and search and see all the containers and all the aliases that are exposed. So for example, there's over 200 of these, and they range everything from biocontainers to the brain imaging data structure, Jupyter and NVIDIA, pretty much all the sort of hardcore use cases for HPC. Okay, now you choose one, let's install it. So here I am installing Klingo. The container is pulled using Singularity. Since I'm a user, I would then need to tell lmod to use this modules folder. I then load my module, and you'll notice here when I'm typing, I'm pressing tab because there's automated completion. Once I do that, that executable, well, the executable, it's not really an executable, it's a container command, is available on my path, and I can interact with Klingo. So there I am saying that there's a dinosaur named Vanessa. Huzzah! These commands can get pretty complicated. So let's say you're a user and you want to run a notebook. you would normally have to remember this really hugely complicated command, everything from interacting with Jupyter, knowing where things are in the container, doing binds, specifying a port. And what SHPC does for you is it makes this so easy to do. You just run notebook, done. Okay, great. So we've kind of shown how it looks like, but what does this registry actually look like? Well, it's a file system registry. So if you look in the root of the repository, you'll see this registry folder. Here you'll recognize, Docker, unique resource identifiers, namespaces. So for example, if we look in biocontainers, we see biocontainers Abyss. That would coincide with the biocontainers Abyss container on Docker Hub. Within each of these folders, we have a container YAML file, and that's going to specify everything about this entry. So for example, here we're looking at the biocontainer SAM tools. Here's a unique resource identifier on Docker Hub. There is the latest tag defined, which is a tag and a digest. You can also define one or more tags so that they're available even if it's not the latest. The filter is important because that tells the bot that's going to update this recipe, only look at the tags that start with V because those are released versions. And then finally, there's a set of aliases. So this is a tiny one. There's only SAM tools in the container, but this list can actually get very large if the container serves multiple things. I mentioned automation. We have a bot named Binok, which was created by the very talented Alec, who's doing an internship at the lab this summer. And Binok basically opens a pull request every day to update versions of containers. So here's an example of updating Beast 2. Binok has discovered there's a version 2.6.4 that is now latest, and he's updating that accordingly. Also, we have automated testing of containers. So if you apply the container recipe label to any PR, it'll automatically test actually, building the container, loading it as a module. So back to this formula for collaboration. Okay, we started with a need. We then moved on to say, okay, how can we meet this need with an idea that kind of fits into current practices, so environment modules. And guess what, folks? Now it gets hard because now we have to figure out how to make a contributor-friendly learning environment. And so the obvious answer to this as well, you need really pretty documentation with a getting started guide and how to install and tutorials, and maybe you have a little branding and it's colorful or a cute robot or something like that. Once you kind of do these things, if you're like me, you check off all the boxes and then you say, okay, well, what do I do now? I mean, is this like a field of dreams kind of thing? Like if I build it, they will come. And the problem is that when you really kind of zoom out, there are projects, to be fair, that we collaborate on, and they're kind of set up and intentional. But for the most part, for these small projects, we kind of work in these small silos. And there's this question that I think we need to ask more. How do we work together? Because we have so many things in common. We are, for the most part, using HPC to some extent. We're using common kind of open source software that helps us to do things on HPC, like Singularity containers, which we talked about here. And we also really get excited about open source development. And I probably don't need to convince you of this, but there's many benefits to collaboration, everything from better ideas and approaches to using best practices, and we can also learn and grow from one another. And as you know, there's also a lot of reasons that we shouldn't collaborate. So it's very expensive in terms of time and effort, setting up those Zoom meetings and the Google documents. And it's also because there could be concerns about intellectual property. Maybe there's a security clearance required for a national lab, so it's just not possible. And it's also just expensive. So if you wind up needing to actually pay people for their time, you have to get funding, and well, maybe you can't afford it. Okay, so at this point, I realized I wanted to do something. I realized that I saw this opportunity, but the problem was at my institution, I didn't have a good sense. I didn't have a good sense of a baseline of how we were doing. And so I started by saying, okay, maybe I can figure that out by looking at data. So I started at the LLNL software portal, and this has like about the 735-ish packages, different open source software. And I won't show you all the plots because I don't have a lot of time for this talk. But overall, what I saw is that we're doing really well on a few key projects, maybe just 3. They're really excelling in attracting external contributors. But what was interesting is that the projects at my institution that had the most people working on them internally, they're on GitHub, they're public. Those were not the projects that had the most people working on them externally. So there's some kind of mismatch between like what the lab thinks is important and what outside people think are important. And maybe it's also because these projects aren't contributor friendly. And then I saw this long tail. So I will show you a quick graph to explain what I mean. So I was looking at contributors broken down by internal versus external at the lab. These first couple of bars are actually just a couple of projects, so SPAC, MFEM, and ZFS. So it's less impressive than you think. But here's the problem, okay? This is only 1/6 of this graph. This thing just goes out into like infinity, not infinity, but like way off of the browser. And there's this long tail of projects that people are working on at the lab, but I personally don't know about. And I bet you most people out there in the wild of the open source community don't know about them either. So again, back to this question. Now I see that I think we can do better. And the question comes down to how. So my plan of action, and I'll finish this up quickly. I want to create something called Contributor CI, the set of tools and procedures that you can use to assess contributions. And I think I want to start with a baseline. So I'm going to create a GitHub action that's going to collect metrics to measure these contributions. And it's going to automated do it for you over time so that you can see how a project changes or many projects change. And then I think the next step is to do this thing I'm calling a contributor friendliness assessment. And this is a little bit manual because it means looking at a repository and seeing how contributor friendly it is. And then finally, when we have that information, I think we can actually take proactive action, keep the timestamp of when we did it, and then see if anything that we've done has influenced the metrics that we're collecting. For the contributor friendliness assessment, just to give you a sense of what I want to, the kinds of questions we want to ask, it's about use cases and what's in the documentation. And then for the action, well, this is kind of also straightforward. Identify things we can do them, and then see if they had any effect. So I want to finish up today and give you a call to action, because I think this is something that we should care about. If we're all working on similar things and we have similar goals, why is it that it's not easier to work together? It is so hard to work together across these very siloed RSE communities. But maybe, I independently can't just like fix this problem, but I can reach out to you and say, can you look at your institution and really do an assessment of, what is being developed, who's developing it, what kind of developers are there? Are they internal? Are they external to your institution? How contributor friendly are your projects? And then once you have that information, to take action to improve the scores. And I don't have tools or anything developed yet, but I will invite you to kind of join me into thinking about this and working on this. So that's all I got. I'm out of time. Thank you, everyone. Are there any questions?
Thank you very much, Vanessa. We have one question, and I would leave it maybe for the moment to the one question if I don't see another hand. So Reed, would you like to ask?
Sure.
Yeah.
So I attended, it was a really great talk, I think at SciMCSE by people at NERSC on containerizing their HPC clusters for collaboration. And one of the things they brought up was security, right? And I was really curious, like, what are your thoughts on ensuring security when it comes to the use of HPC, of these containers in HPC? Or put another way, let's just say, how do you deal with malicious actors trying to turn your HPC cluster into a Bitcoin mining operation, right? Because the more you open up to the outside world, the more you want to make it easier to collaborate, that becomes a concern.
Right. So at least with Singularity containers, security has been something that's been really important in the development all along. So in terms of actually execution, you can't become root. Are you familiar with Singularity or? I
am.
Okay. Yeah. So you probably know you can't become root. It's sort of the motto is like untrusted containers in a trusted environment. And I guess in terms of like what containers people install, that really comes down to the use case. So if an admin installs this, just like they provide software with LMOD or the older TCL environment modules, then they have total control over what containers are added there. If a user does it, then it's really no more risky than just having Singularity installed in your cluster, because any user can just pull a container and use whatever permissions they have. So this tool doesn't add any additional security risks that wouldn't already exist if you use Singularity containers.
One other small question, if we have just a second, would just be, what are your thoughts on what kind of contributor metrics would you foresee being valuable, for kind of contributor friendliness?
Oh, that's a really good question. So a lot of people always kind of like flock to stars. I think stars are sort of they do reflect when a repository has been seen a lot, but they can also be a false metric. For example, I had a package that just randomly hit Hacker News and it got like 700 stars in a day. And I was like, this package isn't very good. So I think in terms of metrics, what I'm just starting with is very logically like who is contributing to this package. So contributing means like, actually making commits, opening issues, pull requests, that sort of thing. Because I think what it comes down to is like who is actually like actively doing something on this GitHub repository. And I think there's so many packages at the lab that I think that's a reasonable thing to kind of start with. Because as you saw with that long tail, which is like this long, most of them are like really have tiny just in terms of the total contributors. And I'll tell you a really quick little story that I know this is true. So I needed to delete like 1.5 million files on one of our clusters. I was just going to make a job and then, remove RF. And then so Todd Gamblin told me about MPI file utils, that it has a DRM, like a kind of like a parallel remove command. And it like changed my life. And like, this is just a tool that's out there that I had no idea about. And I was like, if this is just one of these little commands in a package, like there must be so many more, but we're just like, we're sort of using them, but we're not like doing a good job and being like, hey, this use case is interesting to you over here. Take a look. So anyway, that's the story.
Oh, very nice. Gotcha. Thank you. It's a good presentation.
Yeah, thank you very much. Great presentation from all four presenters. So welcome back, everyone. So we have our next session with 4 talks, and it's my pleasure to introduce Naim Khoshnevis. I hope I said that right. And he's from the Harvard University. And he will talk about refactoring researcher develop statistical ARP packages, technical details and challenges. This introduction is that he has a unique interdisciplinary educational background, and he enjoys listening to researchers, computational problems, and developing solutions. Take it from here.
Thank you so much. Hello, everyone. Thank you so much for joining this presentation. My name is Naim. I'm a research software engineer in Mahmoud's team at Harvard FASRC, and I'm going to talk about one of our recent projects that is about refactoring an R package. FASRC organization at Harvard has several teams. I'm a member of research software engineering team, and we are collaborating on refactoring and developing a statistical package with a group of amazing biostatisticians at the School of Public Health. The package name is Causal GPS. It's an R package for conducting causal inferences in the context of observational studies and answering questions in that regard. For example, what would have happened if you had stopped smoking 5 years ago? The goal of the project is to have a standard open source software which is optimized and well designed to use available computational resources efficiently. Like many other RSE projects, this project is interdisciplinary. We have domain knowledge, which is causal inference. We have cloud computing, big data problems, HPC related tasks, and also software engineering. The role of RSE, or a research software engineer in this case, other than design and implementation, is to build effective communication with these groups and have enough knowledge from each category. Obviously, no one can be on top of everything. I think it is essential to know what can be done, even if you don't know how to do it. In that case, you can ask right questions from right person in different teams. There are 3 major categories that can be improved in researcher-developed packages. First, you can take a look at the software development lifecycle. This includes unit testing, continuous integration, version control system, logger, and documentation for developers. There are some requirements for the package itself, and they depend on the language you are developing the package in. This package is in R, and it has its own convention and internal structures. After having a standard open source package, you can take a look at the project at the code level. which itself includes different subcategories. I will briefly talk about them with an example. In converting the software into a standard package, modular programming is very important. In our programming language, writing nested function is common. And it makes it very hard to test the individual functions and improve them. So we manage the complexity of the program by breaking it down into a smaller, simpler, more manageable section of code. So we break 4 or 5 available complex functions into more than 30 different functions, and we added more than 70 tests to check different parts of the code. We also activated continuous integration using GitHub Actions. Then we started to train researchers to follow a standard version control system practices and Git branching model. We follow the tips given in a successful Git branching model white paper. For example, following this approach, master branch always hosts the most stable version, and the develop branch hosts the less updated version of the code, but might have some bugs here and there. This step is very important because while you are improving the code, others either want to use it or work on different part of it. So we need to make sure that they can collaborate smoothly. After these steps, we have a software that is following standard software engineering practices. However, it might not be efficient. Now we can take a look at code itself. If there is an algorithm or step-by-step implementation guideline, that would be very good. But most of the time it's not there. In that case, you need to go through the code and do reverse engineering and understand what is going on, as we have done here. In this step, you can find the bottlenecks and fix them. For example, here we have some computation that is CPU bound. There are some tasks that is repeated inside the for loop. And also there are some implementation that creates a large matrix and cause out of memory error in large data sets, which requires a better implementation. So in this case, we parallelized the first one and we took the repeated computation out of the for loop. And we wrote the last part in C++ with a better design, which now instead of using more than 100 gigabytes, it requires a couple of megabytes of memory. You can always take a look at the third-party packages and see whether the code is using those packages with full capacity. For example, here they are using XGBoost package through Super Learner package. However, the default number of cores is set to 1. So it needs 1 extra wrapper to use all available cores. Another place to look is the language-related functions and features itself. Here we are working on our package, and I have reviewed many codes that they are using reduce command to convert a nested list into one list. As you can see, using do call command in this case can improve the performance even up to 1,000 times. So these are general steps that I could talk about in this limited time. Following these steps, one can convert any researcher developed R code into a standard R package. The package website has all the information for users and developers, and this project is under rapid development. Now I would like to talk about, briefly talk about tips, challenges, and learned lessons. One of the challenges in RSE projects is not knowing when to stop. Of course, one can do the minimum requirements based on job or project descriptions. However, I think it is not a good idea. I think we need to consider most of these features, even partially implemented. For example, for the logger, you need to implement infrastructures with documentation on how to add a line of log to the code. So through these steps, researchers can add them later if needed. The expectation is very high, and the future projects can be dependent on the quality of the current work. As a result, we need to meet the expectations. Of course, we can argue that the high expectation might not be reasonable. So to address this problem, we need to build a good communication. It is important to follow the Agile software development process. I know many scientific package development fits best in waterfall development approach, where you develop features separately and put them together in the end. But I think it's very dangerous and can build up a very high expectation unless you sit with the researchers and completely explain how the process works. It's a good idea to try to help the researchers to visualize the final product, although it is not fully completed. You can use placeholders for features that are not implemented, and you need to make sure to catch most of the errors and return good error messages. A comprehensive logging at different levels can help them to see the process. And even sometimes taking snapshots can be really helpful. For example, here they might expect to see 20 times improvement in the performance if they are using 20 cores. However, as one can see, all the cores are active, but the algorithm is not embarrassingly parallel. This is another way to convince them that the problem might be in other places rather than the implementation. The other important tip is paying attention to the details. For example, you might see that the original code requires at least 64 GB of RAM, but researchers think they have done it in 20 to 30 GB of RAM. So you should clear this misunderstanding. Or most of the time they share a folder that has many codes, and inside that there are many different versions that may not be the one that you are looking for. So you need to, it will be very helpful if they provide a code that has simple entry point, for example, run this.r. And the papers are good for understanding the big picture, but it's not good for implementation. And for implementing details. Never make assumptions based on that. For example, the results in the paper is generated with this version of the code that you have. And definitely it is not a 9-to-5 position. Research software mostly is designed based on ideas that have not been fully tested before. It might work with the small data, but you are not sure if it should give the same results with big data. Sometimes the results are not as expected for new data set. And so in that case, who should you blame? Researchers who produced the idea, or RSEs who implemented the idea, or others? So you should expect a significant amount of verification and validation processes. And in this case, having a benchmark data sets for small, medium, and big size tests can be really helpful because you don't need to worry about different data sets. And also good documentation of the verification and validation process is important for future references. In summary, sometimes you should expect to get involved in research alongside the researchers. And this concludes this presentation. Thank you so much for joining.
Thank you very much, Naim. So, any questions from the audience? Comments? Great presentation. Yes, I agree. So, Ian, is it a hand up or a clapping? Okay. So sometimes I don't see that so well on my screen.
I could ask a question.
Okay.
On refactoring in general. So whenever I speak with someone about refactoring, sometimes the response I get is, I know my code is ugly, but it's fast. And I'm afraid that if I make it not ugly, it'll become not fast. So how do you approach that conversation, right? with teams?
One of the problems that we have when we are dealing with this kind of problem is you are not the only person who is working on this code, and some other people may want to work on that. Even if you want to come back and see if there's a problem with the code, you cannot understand what's going on. So it's a better idea to polish it and make it less ugly.
But that's the thing. Now they say, but oh, you want me to share my code? But I'm afraid that's the thing that naturally follows from that.
Yeah.
Yeah, that is a very natural reaction. So a little bit, I think sometimes it's also already telling the students that it's also okay, and that they never should expect that there is source code that is error-free, bug-free. We have to get over that. You know, if it's not a hello world, it won't be bug-free.
Right.
Yeah. Okay, thanks again, Naim. And I would then introduce the next speaker. Next speaker is Joe Fry, and you can probably already start to share your screen from Sanya National Labs. And he introduces himself like when he's not working on compiler tool change and common environments for HPC, he's chasing his two sons, 4 and 2, with his knife Nora. And he will talk about Spec Configuration Manager, automatic tool change installation. And I thought I've seen his name.
Joel, if you're talking, we can't hear you, just so you know.
So
he is
yes,
here, Sandra. He's just having a hard time with that.
We see he's waving.
Okay. So if you need, can you type something in the chat, or do you have a problem with technology? Yes, that is good. Okay.
So, oh yeah. Oh, yeah, you also got
nice
a laptop. Oh yeah. I also had some technical issues that to resolve.
Yeah. So we have that. We can give it another minute. So you probably have to log in if you have to give all the configuration and that you're allowed to share your screen.
Yep.
Yeah.
Well, if he needs a minute to work it out, would it be possible for us to flip around to talk, or I don't know how long it'll take?
I mean, also, if he can't figure it out, Joe, with your permission, I can always give it to.
So the other thing could be also if he gets this audio to work, Miranda, you could maybe show the slides and he can talk to it.
Yep.
So we give it another minute. Otherwise, we can also switch talks. So don't feel any pressure here. I mean, I see you now. So maybe just not if you want me to maybe switch talks that you get time to. Yes, okay. So I hope the next speaker, oh, of course, I wish also the next speaker that has a fantastic new laptop, but hopefully it works.
So did we want to fast forward to the next talk? Because our talk on loading the environment kind of builds on top of Joe's talk on establishing that environment. I don't know what we want to do there. We can give them backwards. I guess it doesn't matter.
We could also put my talk, which doesn't necessarily build on yours or Joe's talk. Jason, do you think that would be a good idea?
Yeah, I don't mind if that goes now.
Okay. Is that okay with the presenter or the organizers?
It's okay with me. I think I hope that all the sessions are, or let's say that also the attendees are for the full session here and not aiming at exactly one talk and coming exactly at the time. And so, so we do that. So yeah, maybe David, should we go then for your talk?
Sure. All right. Can everyone see my screen?
Yep.
Okay.
Yeah,
Good.
looks good. And I give you the short introduction. So David Collins, he's also from Sandia National Labs. And his introduction is, I'm a DevOps engineer at Sandia. So take it from here.
All right, thank you. So my name is David, and I'm going to be giving a talk on a Python library that my colleagues and I have been developing over the last few years and refining it. It's basically a library that helps us troubleshoot issues in our Python scripts when we run them through automated DevOps pipelines or hand them off to other users. And so let me give a little bit of background surrounding the development of this. Our DevOps infrastructure a few years ago consisted of just a pile of bash scripts that we ran through DevOps pipelines and handed off to other users. And we were finding that the bash scripts were, number one, not maintainable, and number two, whenever users ran into problems, we found ourselves going a lot of back and forth between the users trying to gather diagnostic information to help us figure out what the problem was. So that's just to set maybe a little bit of backdrop for this library. Let me start by framing the problem that Logger tries to solve. So consider this simple bash script that fetches the CMake source from the web and builds and installs it somewhere in your home directory. If you were to hand this script off to a user, it might behave differently on the user's computer than it would on yours. For example, say the user is behind a firewall that doesn't allow HTTP connections except through a proxy, but the user doesn't have the HTTP_proxy environment variable set. Then the user might see this error, failed to connect to GitHub connection timed out, right? Or maybe the user makes it as far as the configure stage of the script, and the user happened to have the CXX environment variable set, but not the CC environment variable set, because a lot of configure scripts will look at those two environment variables to figure out what compiler to use. And if you have maybe a mismatch of compilers, you might see oddball errors like the one you see here. So when we're troubleshooting problems, sometimes just an error message isn't enough to solve the problem in and of itself. So in the examples that we saw, it might be also useful to have the environment variables before the commands were run, right? But in general, it might be handy to have some other information when you're trying to troubleshoot. For example, what's the working directory of each of the commands? What machine is the command running on? What's the user group that the command is running as? What's the UMask governing the default permissions that commands will generate files with? What's the return code of each of the commands in a script? What's the ulimit constraining the script? What is maybe the duration of each of the commands running? Or what's the resource usage on the system while the commands are running themselves? So we created a Python library that will run shell commands, and it will keep track of all that context in an HTML log. It'll give you the command, a description of the command, all the things I just mentioned. We decided to make resource usage measurements optional. And also we added a feature to optionally strace or ltrace your command if you're one of those advanced users who likes to do that and you're in dire straits. So let me give a high-level description of how you might convert a shell script to a Python script that makes use of our Logger library. So at the top half of the slide, we have a shell script that runs cmd1 and cmd2 in a different directory. To create the equivalent Python script using Logger, first you'll import the Logger object from the Logger library and the path object from the path lib. Then you'll instantiate a Logger, providing it a name and a directory wherein it's going to store the HTML file. After that, you can start using the Logger's log method, providing a description of every command that you want to run along with that command to run. You can also optionally provide a directory in which to run the command. After you call logger.finalize, the Logger will create an HTML file with all the information that I just mentioned. Now, one thing to note is by default, Logger does not output standard out and standard error to the console as the commands are running, but you can change that by providing optional arguments live standard out and live standard error to the Logger's log method. Also, if you wanted to say capture resource usage, you could provide the optional measure argument, providing it a set, which is some subset of CPU memory and disk, and that will appear in your HTML file. Let me give a concrete example of a bash script being converted into a Python script using Logger. So this, on the top half of the slide, we have a bash script that basically pulls the Flex source from GitHub. It'll CD into the location where Flex was downloaded, and it'll run autogen. Then it will run configure, providing a prefix on where to install. Then it will build libcompat.la, and then it will build the executable files and install them. So an equivalent Logger script will have 5 calls to the Logger's log method. The first one is for cloning the Flex repository. The second one is for running autogen. The third is running configure. Fourth is running building libcompat.la. And the fifth is for building and installing Flex. After you call logger.finalize, what you'll get is you'll get an HTML file with 5 sections corresponding to the 5 calls to logger.log. You can expand any one of these, and you'll get cards whose titles you can click for more information. So if I were to click, say, the standard out card, I would get standard out along with a regex search feature wherein I can show nearby lines. If I were to click on the details title card, then I would get a whole bunch of extra details like where's the directory a particular command ran out of, what's the machine it ran on, what's the shell that was interpreting that command, etc. Also, I would get diagnostics. So if I provided the measure argument to the logger's log method, I would get resource usage while the command was running on the system. And in addition to that, I would get the environment and ulimit cards that I could expand. So the environment is just a list of environment variables as they were set just before the command was run. And that's also regex searchable. And ulimit is simply just the output of ulimit.a right before the command was run. Well, you get this for each command. So basically what I showed was how you could use the logger to generate an HTML file that gives you command description, duration, and a whole bunch of other diagnostic information in case something was to go wrong. But there are a few features that I didn't have time to cover for sake of time. For example, you could say if you want to figure out what programs the make command was launching, then you could strace that make command with the execve expression filter. Or if you want to figure out, say, what environment variables your make command was reading, then you could ltrace that with the getenv filter, if you happen to be familiar with strace and ltrace. Also, one thing about Logger is that it's actually stateful. So if you were to run, say, export variables value, or you were to run, like, say, sudo -i, then subsequent logger.log calls would actually run as root. And this is unlike Python's os.system or subprocess.run functions, which would just spawn an independent shell for every command you run and run that in its own separate shell and then terminate the shell. Also, logger.log returns all that information that you saw in the HTML pages in a map in the Python code. So if you wanted to use any of that information in your Python scripts, you could do that. Also, you can create hierarchical HTML pages via child loggers, and each child logger gets its own independent shell in which you can run commands. And if you were to run commands in a child logger shell, it doesn't affect the parent logger, nor does it affect any of the other child logger shells. So I'd like to give maybe a few examples of some of the problems that we've solved in the past with Logger. So we had a build script at some point, which would build and test our code. But when we were in the build phase running make -k -j32, we're getting this mysterious no space left on device error, and our compilation would just terminate in the middle of the make. And when we ran df-h, we saw that there was plenty of space, and not just in the directory in which we were running. We were looking at all the volumes, and we didn't see any of them filled up. But one of the things we realized was that when we were graphing out our used disk space on the temp volume, what was happening was the compiler was creating a whole bunch of the compilers running in parallel. We're creating a whole bunch of files in /temp. And once temp got filled up, then the compilation terminated because we ran out of space, but they would also clean up after themselves when they were done. So they would kind of hide the evidence of the problem. And we didn't figure that out until we looked at the disk usage on /temp. Another problem we ran into was when we were, say, building our code, we would see, oh, wow, random terminations by the kill signal. And we're like, huh, why is that? And when we were graphing out memory usage, we realized that, oh, wow, okay, so when we're running make minus J80 for, building with 80 cores at a time, we were saturating the system memory to 100%. And so the Linux kernel was probably just running out of memory kills, killing our compilers that were taking excessive memory. So with all that said, unfortunately, at the moment, Logger is currently only available at Sandia, but we hope to release it to GitHub by the end of this year. And a lot of that is going to be incumbent on me figuring out how to get around red tape to actually put this on GitHub. But for now, thanks for listening, and I will take questions.
Thanks for a great talk. So there are several questions. Okay. Let me see. So one is from Reed.
Yeah. Great presentation, David. Loved it. It was great. I'd love to get your take on a question. So what do you think is the human impact of having good logging, right? I know there's one hand, there's like the element of it just being able to fix bugs and understand the program, but how do you see a connection to having good logging capabilities and making teams, say, less stressed or able to work together better? There's like a teaming angle here, and I'd just love to get your thoughts on that.
Well, that's a fantastic question. So I think one of the things is that at some point, sometimes I've realized that certain users tend to like to stick to their tasks, and they don't like to spend extra time troubleshooting things, right? The less they have to interact with you, the better, which, on the one hand, I can kind of understand. On the one hand, it's not, conducive to a good teaming environment, but on another, maybe they're pressed for time and such, right? And so basically, it does aim to reduce some of the communication, say, between you and a user, or maybe when you're running on a pipeline, you don't really have anyone to interact with. But at the same time, I think it's removing mostly overhead and not maybe meaningful communication that you would make between you and a user, right?
Yeah.
So
nice.
Yeah, thank you.
And I mean, it's already discussed a little bit in the chat, but so the question about how long the process takes.
Oof, yeah, this would actually, oh yeah, so this would actually be my first time trying to go through this process, so I'm not sure. So part of it's just me figuring out what red tape there is, because I understand that I can't just push it to GitHub. Otherwise, I'd probably just do that. But yeah, unfortunately, I can't speak to how long the release process takes at Sandia.
Okay. So let me see whether I see any hands up. Good luck. Okay.
Yeah, thanks.
Okay, so Todd, you want to say a sentence, and then I think we go to the next speaker.
Oh no, just I hope that the software release process isn't a huge burden for folks at other labs. I know that like at Livermore we had to push really hard to get what we have now, which is a scoped release process where you can put something out as open source and then continue working on it in the open, as long as it doesn't sort of leave that subject area. And that's been hugely beneficial, in addition to doing things like speeding up the release process itself. So yeah, good luck. Hopefully that can be addressed.
So good luck as always. Good. Okay. So now is the question, Joe, is everything working for you? Can you share your screen? Is there a solution? Or should we?
Let's see if he responds. He's turning his camera, I think.
I don't see him. I see black and I don't hear him.
I see black. See black. We see something. Just nothing.
Yeah. So maybe let's because there was an opinion from Jason that he can also give his talk first. So maybe let's give.
Yeah, should I go ahead and pull mine up?
Yes, that would be great. So Jason Gates, he's from Sandia National Labs, and Jason is an engineering physicist turned computational mathematician turned software engineer turned DevOps evangelist who tries to help teams realize a DevOps paradigm shift.
Thanks, Sandra. Can you guys see this okay?
Oh yes, and we see your slides. Cool. Okay. Thanks.
Perfect.
Take it.
All right, let's get started. So assume you've already heard Joe's awesome talk about how they use SPAC to kind of automate the process of generating a bunch of environment modules to sit on all your systems. What we're talking about here for the next few minutes is a tool that we built to help teams consistently load certain supported environments, assuming you have that foundation beneath you already, and then also to help those teams communicate effectively about those environments, standing them up, promoting them, deprecating them, et cetera, et cetera. So let's see here. First question to ask is, what on earth is our context? What are we trying to do? Where? Why? To give you a rough idea, we're talking about supporting teams where we need to support roughly 50 different compiler plus third-party library stacks. And we're supporting all that across 10 or so machines, some of them vanilla like Red Hat, others much more interesting. And we're doing that for codes that have dozens of configuration knobs that you can twiddle this way and that. Our desire was we wanted a unified solution for all users, developers, and continuous integration services. We wanted kind of a one way for everyone, regardless of who you are, to interact. And then specifically, the inclusion of developers there means we needed a way to quickly switch between environments in the midst of doing your, cloning the code, making your changes, doing that kind of development work, testing it, debugging it, checking it on other environments, on other systems before you say this stuff is actually good to go. That kind of focus means that SPAC and containerization aren't a complete solution for us, but they're part of the solution. So I won't be talking too much to them, but just to give you an idea, like SPAC can help us a lot in building the stuff that gets used in an environment. Containerization can help us in the sense of like if we want to deploy a code and we want to deploy certain containers for particular supported environments, or if you wanted to set up a container that actually has a collection of environment modules in it, either the slowdown tool could be used in the context of helping you create those containers or used on the containers once they're created. So nothing's a complete solution, but you'll see as we go on our kind of design methodology here is we want nice small plug and play little widgets that help kind of fill in this ecosystem. The next bit of context I'm going to introduce you to is something I call the 6 layers, and that is if you're building some sort of scientific library suite, application code, whatever it is, you can kind of stratify what you need to do into these different layers. The first is the operating system, and that's just the base state of the machine. On top of that, we call it the programming environment, and that's just establishing whatever compilers and third-party libraries you might need to use. The third layer then is how to consistently load particular sets of those compilers and TPLs, particular tool chains. Once you have the environment loaded, you can move on to configuring the code. And then there's a question of how do we do that consistently across all the different machines we care about, the different various configuration flags we support. Beyond that, layer 5 is just kind of a nice user interface to everything below. So as like the user or developer, I don't want to worry about anything below that. I just want to build my code and off it goes. It's kind of the Staples easy button, if you want to think of that picture. And then the top layer is orchestration services, which is basically how do you use something like Jenkins or GitLab CI or GitHub Actions or whatever it is to orchestrate running your various scripts on various platforms. So what does that mean for today's talk? We're going to assume that the operating system is already taken care of. We're going to assume that the programming environment is already taken care of by Joe's talk, which he'll give us after this one. And then what we want to focus on is in this third layer, developing a general purpose tool usable by any team building on top of environment modules and then configurable by each team to their liking. Next question is, how do we use this sucker to improve reproducibility? So as I mentioned before, the focus is we want one tool with one user interface used by everyone. So that's the user, developer, continuous integration service, whoever you are, you interface to the tool something like this. Basically, you're sourcing a load env shell script and you give it some string. We call that the build name. The example here is just an example Jenkins job name, but it can be anything. It's got some underscores as delimiters in there, and there's some keywords kind of interspersed throughout. The only one that's relevant to loading the environment in this particular case happens to be CUDA. And then the tool does its magic behind the scenes, and the user is given the appropriate CUDA toolchain on whatever system they happen to be running on. So then they can do a little happy dance. How does it work? I can't give you a live demo, but I can kind of simulate one with some pictures here. First thing is, once you're on a machine and you have access to the tool, you can list the available environments, and it'll tell you, look, it looks like you're on a RHEL 7 system. These are the various environments that are available for you. You can call out an environment specifically by giving it the full environment name, or sometimes you may have aliases associated with them so that you don't have to type out the entire long environment name that you want to pull up. So for instance, if I wanted to just source load env CUDA, then that would go ahead and say, okay, I found the CUDA alias. I matched it to this particular CUDA 10 environment on your system. I'm going to go ahead and do some validation work behind the scenes to make sure that environment actually works on your particular machine. And then ta-da, environment loaded successfully. If you then wanted to take a look at what's loaded, you could look at the module list and see, okay, there are a couple of modules that are loaded up there. If you want more eyes into what exactly is happening behind the scenes, you have the ability to specify an output file. And what that'll do is it'll actually write a bash script that is what is used to actually load that particular environment into your current shell. So you could take a look. I'm just looking at the last little bit of the file here, but you could see there's some module operations, there's some environment variable operations, and these functions are actually defined higher up in this file. It's just a way of doing some extra checking in place. But that way you have this script that shows you exactly what you're doing. So how does that help with reproducibility? Well, CI services like Jenkins or whatever you're using, they can archive that load matching env shell script. You can call it whatever you want. That means developers should be able to exactly reproduce the environment as long as they have access to the machine that was generated on. Similarly, if developers are trying to debug something, they can hand around this load matching env. So you can say, here, this is exactly my environment. Also, something that I would value greatly is if you're getting bug reports in your issue tracking system, users can include that when they file a bug report, so you don't have to spend a few weeks going back and forth with the user to figure out what exactly their environment was. And again, the focus here is everybody, regardless of who you are, is doing the exact same thing in the exact same way. The next question is, how do we wind up improving collaboration when we're talking about environments? Because historically, trying to collaborate involves, emailing a bunch of scripts back and forth, a bunch of questions like, how did you set your stuff up? Can you give me the output of env? Can you grep for something or other? And it can be a long process to get to where two humans are actually speaking the same language, talking on the same page. Now, with the use of this tool, everything that you need to communicate within your team that's adopted usage of it is contained in 3 configuration files. One specifies what systems are supported by your team. The next one specifies what environments are supported on those systems. And then the third one tells you what exactly has to happen to generate each of those environments. The reason we focused on configuration files is they're clear and succinct, they're easily human readable, and they allow us to get straight to the what of loading environments. And then the rest of the tool, which the user should never have to interact with, abstracts away the how, kind of hides it behind the scenes. To give you an idea of what these suckers look like, the supported systems configuration file will have a handful of sections in it. If you guys are familiar with like a .git config file, this is kind of the same type of syntax you might see, where you've got a section that has some name to it and then effectively pseudo commands within that section. So it will have sections corresponding to the different systems you support. And then the contents of each section is basically a list of regular expressions to match a host name against, to match to the system name. If you jump from there to the supported environments config file, You similarly have one section per system name, and then for each system, you have a list of which environment names are supported. So those are the things listed in teal. Optionally, you have the ability to give an environment name an alias so that the user can access it more quickly with fewer keystrokes on the command line. But in terms of scripting things up, we recommend for the sake of being explicit, you use the full environment name. And then finally, we jump over to the environment specifications file, and you see kind of a bunch of stuff here. One is if we go down to the bottom, you have what we call full environments, that are intended to be loaded. And so they will correspond to the environments that show up in the previous config file. And then there's kind of a pseudo language embedded in this config file where, for instance, use is a particular operation that allows you to go up to a different section elsewhere and kind of paste it in place. There are other commands embedded in these sections, module commands in green, environment variable commands in teal. And these are, with a very limited language, allow you to establish whatever you need to actually set up the environment that you need to create, or the whole list of them. And if we go back to the beginning, 50 different tool chains across a dozen machines, etc., we're only talking a couple hundred lines of configuration in these 3 files. So a couple hundred split between 3 files, which is not that bad for maintenance. Last question is, how do we focus on long-term sustainability in doing all of this? One big thing is we've really focused hard on modular design of reusable components. So from the user's perspective, all they know is there's some load env tool, but really that's built up of about a dozen really small bite-sized components that are intended to play well with each other, but at the same time to be easily extensible for future use. In addition to that, we try to put into practice all of software engineering best practices here. Using continuous integration with PyTest and Sphinx, making sure our test suite always passes, our coverage never degrades. Sphinx needs to build warning clean. We use GitLab pages to deploy documentation. So using that in all of the dozen little widgets you saw on the last slide, that's kind of just to make sure, if any of us goes and gets hit by a bus, make sure that all of this, continues to be easily usable by whoever happens to fill in our shoes. Another example here to kind of demonstrate how we focus on increasing bus factor. These are just 2 of the widgets that I showed you 2 slides ago. But for these 2 widgets, we've got kind of a documentation to code ratio of about 1.5, and then a test to code ratio of about 2.5. So again, the focus is on making sure that we do a really good job making sure this stuff is easy to come up to speed on, easy to maintain long-term. We don't want people to try to reinvent this wheel, 3-5 years down the road. We want it to be easily extensible so that we can keep using it. Okay, last question. I lied when I said that a moment ago, but last question, what are our future plans? And that's basically prepare for release, finalize our deployment plans. You heard David's concerns about open sourcing, and we have similar question marks there to figure out what the process is to get this out to the rest of the world. And then also the last thing we're in the middle of now is also developing a tool for layer 4 in the 6 layers. So that's figuring out how to manage consistent configurations across all those machines, and that will be utilizing all of the dozen widgets we built in making up this tool. So with that, I will stop sharing and open the floor for questions. Thanks for your attention.
Thank you so much for a great talk. So let's see whether we have any people with their hands up. So I would have the question, when you really integrate these processes in different teams, how fast is the take up of the system?
Oh, you mean how easy is it to get up to speed with the tool?
Yeah.
So I can't give you hard numbers yet because we're still just in alpha testing phase, but I can tell you in the midst of alpha testing, we've run it by a handful of kind of power users of existing stuff that's in this space. One example was there was one person who was able to get up to speed on all the config files and figure out what they meant. And it was about 10, 15 minutes to understand what they were doing and how you might go about modifying them. Actually, David, if you're still on the call and want to unmute yourself, you might be able to give your perspective as kind of an outside early user.
Yeah, I think I've got a probably similar story, although I'm not, I'm not the smartest pencil in the box, so I'll probably take about twice as long. But yeah, I think it's probably took me about half an hour, I'd say, just to poke through. And I pretty much approached it from not like, I'm going to try this without even looking at the documentation and just see if I could get things right. I'm sure if I looked at the documents, I probably would have gotten it faster. But yeah, half an hour or so, and I could come up with a decent set of environments, standardized environments for a new system, like one of our clusters.
That's cool.
Yeah, thanks, David.
That is really cool.
So yeah, our hope is to figure out the open sourcing process so we can get this in more hands out there, so that we can be contributing to this larger ecosystem of little widgets to help us all operate in this space. No ETA, but we're working on it.
Okay, cool. So I don't see further questions, so thank you again. So Joe, I hope you could solve your problems, or maybe one of your colleagues can show your slides. I see you are still online and unmuted. Can you maybe say something? Okay.
Miranda, do you have the ability to share the slides and
I
present?
do.
Okay.
Okay.
Sorry, Joe. I feel so bad for you as I'm watching you futz around with the computer. I know the pain.
Jim Willenbring actually gave a good idea. Joe, can you dial in and I'll share the screen and you can do the talking?
Yeah.
Oh, just call in on the phone, you mean?
Mm-hmm.
Yeah, I don't want to deprive this audience of his excellent speaking voice.
Okay, so I give the introduction. So Joe Fry is from Sandia National Labs, and when he's not working on compiler toolchains and common environments for HPC, wait, I gave this already. I'm chasing my two sons. He's chasing his two sons, 4 and 2, with his wife Nora. So, and since Miranda shows the slides, she's also from Sandia National Lab, and she's an early career research software engineer with a background in applied mathematics. She enjoys reading, baking, lifting, and hanging out with her orange creamsicle cats, Suko and Leroy. And when we see the slides, yes, we see them. So Joe, can you try the audio? And if you say something, I don't hear you.
Hello, how is this? This is Joe. Did I make it in?
Yes, you did.
You made it in, yes.
You made it.
The
Oh,
audio is really good. The audio is really good.
Well, thank you all for being flexible and patient with my new laptop problems. So yeah, I guess we just get into it. It looks like Miranda's got the slides up, since I'm seeing them. So I'm Joe Fry. I'm from Sandia National Labs. I've been there about 6 years, and I work on sort of compiler toolchain kinds of things and common environments on HPCs and different systems. And this work is done with Miranda Munt, Henry Swantner, and John Pellegrini. And basically what I'm going to present to you is a SPAC configuration manager tool that we have. So we are from the Department of Engineering, Software Engineering Research at Sandia. It's been talked about a couple times now. And SPAC, for those of you that don't know, is a sort of a package manager for HPCs from Lawrence Livermore National Lab. It builds from source, but we found that users complain of a high level of complexity, especially for the use case that we were trying to, how we're trying to deploy software for them. So just to give a little bit of history and to sort of give you an idea of what we are, what the use case is and what we're trying to do here is originally we had created a homegrown tool to deploy software for these scientific applications, right? And for those of you that work in this space, you know that this is very, very complicated. Originally, it was done by a member of the project team, and so work was duplicated across many different teams, and it was hard to keep things consistent, and it was difficult to sort of get common environments, right? So you have high maintenance costs, you have duplication, you have difficulty in maintainability. At the time, SPAC was, I think it was maybe a new project that we had done this, but it was not in the state that it is now. And so at some point it became obvious that we needed to still support our deployment of software for all of our teams. But that it was, the original tool was not designed for the scope that we had, and it was sort of like I said, it's kind of a homegrown tool, and so required a rewrite. And so we decided we should utilize SPAC so that we get, we can take advantage of the larger community. We can do higher, a little more platform support. I like that the package configuration lives with the maintainer who sort of volunteered to do that.
Joe, do you hear me? There's something like really loud ticking noise. I don't know. I think everyone else is muted, so I looked through the list. It should come from you. Okay. I don't know. Do you hear that? You might have still also your audio on your computer. Maybe if you shut that down.
Okay.
And have the audio on your phone. That might be something like back noise or.
I don't know. Is it still going? Is this an ongoing tick?
Yeah.
Yes.
It's like being at AWE.
It's softer now than it was before.
Okay, hold on. There was a fan in the other room. Was that it?
Nah, I think it's just on the line.
It probably really, I mean, I hope that if you would maybe turn off your audio on. Let me mute you on your laptop. No, that doesn't help. Oh, maybe we just continue. We can hear you.
Okay. All right. So I guess what I want to convey in this part of the talk is basically that we have this pretty complex set of software deployed on our systems, and there's a nice, easy module interface to it. And this is kind of what our users have become accustomed to, right? And it's pretty consistent across systems, and so we're using SPAC to try and recreate that use case, right? So core requirements for this tool is we wanted it to be accessible, right? One of the things with the other tool that we had was that it was really difficult for people to use and to modify. So we could deploy something, but then if someone needed a special version or some configuration change, it was very difficult for them to do that. So in that, we would also like this sort of single point of entry, which is so there's one file and it's pretty easy to know what to modify in order to do those sort of simple changes, right? Those version changes, those variant changes in SPAC language. And then, the ability to share knowledge, which is, reduce the rework, promote collaboration, and make it possible to easily hand off configuration files to other developers, right? So, to be able to deploy these things consistently, but also to be able to share them outside of maybe Sandia, so that collaborators can have the same environment, right, for reproducibility. There's some sort of dependencies up top, but really what I want to say that, the goal of this is to be as light a wrapper around SPAC as possible. Utilize core mechanisms of SPAC. At the end of the day, we're just calling SPAC install. We're using the environment, the SPAC stacks feature, but just try and remove some of the knowledge barrier for configuration specific, so that the people working on the projects don't have to know all the SPAC details to sort of get something that looks like what they expect, right, on our systems. So with that, here's a little sort of a pseudo demo, right? There's a couple steps with the tool, one of which is the setup. So I'll talk briefly about some of these, right? So one of them is so whenever you set up for your project or on a specific machine, right? You specify in the tool the project name. You can provide this host name, right? And what it does is this generates some template kind of configuration stuff, some of which lives in a project directory and some of which lives in sort of a machine directory. And the idea there is that you can sort of separate out hardware specific details in one area and sort of version variant specific details in another that might be more for your project, right? And the other thing that this host name does is lets you, it can be whatever you want. So if you're on a cluster, you can name it, whatever the name of the cluster is instead of whatever node you're on. Or if you have a really complicated name, you can simplify it here, right? This allows you to use that same configuration on similar machines as you go, right? So here's an example of like the single point of entry that we were talking about. And here we have these sort of categories defined, and these would map pretty much one-to-one to the way that we have been doing this at Sandia for a while, right? So for example, there's this idea of utilities, right? And utility here means these are packages that are built once, like CMake or Git, and doesn't necessarily need to be linked against, right? But you can just run them. Another category would be these TPLs, right? And what that means in this language is, well, the TPLs are all going to get built with the cross product of MPIs and compilers and CUDAs if appropriate, right? So those ones will get built multiple times, whereas utilities will get built once. Base packages are ones that will just be installed once and used in later steps. This is sort of a beginning step. Sometimes something just won't compile with a particular compiler on a particular system, and you sort of have to do this kind of stuff. There's also, in here you'll notice kind of these external compilers, external MPIs, external CUDAs, and this is things that you might define on a system in a packages YAML, right? So that you can use pre-installed compilers, etc., if that's appropriate, right? But the basic use case is that people can just pick this up or pick one up that's similar to the system they're using and just kind of go with it, right? And tweak the version, tweak the variant there. And then when you're going, so then after you sort of generate the, you get your project set up, you do that setup step. The next thing would be to install. And there's, you give it similar options. There's a project, the host name, right? Those will point to the directories that you want to use that have the configuration you want. Another required is the root path. So this is, where do you want it installed? So for me, installing it on some system, this might be a system location. For a user, this would be somewhere that is useful for them. You can break it down by stage, so just do the sort of the base stage or the compiler stage or the utility stage, right? Those kinds of things. And there's a few other sort of optional variants that you can do. So basically, this is the kind of thing that it will spit out, right? So you give it that manifest file, right, and it gives you a valid stack YAML that then it runs stack install on, right? And so this is for those sort of base package case. And in this case, you have one compiler and you're just building some packages you want, and it installs them. And you can see this is a little bit more complicated than the manifest file. And then the next one we have is for the TPL case, right? And so these are things that are going to be built with each compiler and each MPI and each CUDA if necessary, right? And this is the kind of complexity we're trying to extract away from the users, right? So there's just stuff that you have to know where to what to put where and how to get Spack to do the thing you want it to do. And so by sort of generating these files based on those simple ones, we get consistency, and it makes it easier for people to just pick it up and sort of tweak it if they want, right? So the other thing that's in here at the bottom of that is the module, module generation information. So that is all standardized, and so everywhere that we install it, we get these module, the module is generated the same way, right? As I mentioned earlier, one of the features of our existing system is that it has a pretty easy to use module interface on top of this complex ecosystem. And so we just leverage Spack to generate the LMOD hierarchical modules on top of whatever it builds, right? And so this is just a quick example if you haven't seen it, right? Going from top to bottom, if you do a module avail, you might just see compilers. Say you load one of those compilers and do a module avail. Well, then you see whatever was built with those compilers, and so you necessarily have a congruent set, right? Like these things are all compatible because you only see the modules that were built with the compiler you have loaded, right? And same thing with the open MPI. So that's the yeah, I think that's good. Future steps. So we want to add some additional functionality, just sort of generalize it more and more. The more people try it, the more we realize some of these cases that maybe we haven't considered yet. We have a plan to open source it, maybe by the end of this calendar year. But really the long-term goal is to become obsolete, and Spack will just do all this stuff that we want it to do, basically, that's the long-term goal. And I think that is that. Yeah. So I mean, I think the maintenance part of this is as new features, like I just saw this morning, there's a new release, so we're going to go through and see if we can get rid of any of the stuff we have in here. And so as Spack releases stuff, hopefully we just at some point maintaining a Spack YAML is the same. That does this thing is the same amount of work as maintaining our thing, and we just drop it. So that's kind of the goal.
Sounds great. Thank you very much.
I think having tools like this is useful for us for understanding user use cases, honestly, because it really documents what you guys need. So we can look at it and understand better than if you just tried to explain it to us.
Yeah. Yeah. That's good.
So there's a question from Charles. Charles, you want to ask it yourself? And if you're talking, you're muted. Maybe I ask it. Is your work generating any feature requests for Spack?
Yeah, so I know especially Miranda is in probably, it seems like, constant contact with them on the SPAC Slack and putting in tickets and stuff like that. So I think they're aware of what we're doing, and hopefully, like Todd said, this helps demonstrate our use case clearly. But
yeah, that sounds like something that will be profitable for both sides.
Yeah.
Okay, thanks.
There's another question from Brian. So maybe I ask for a moment. So he says he hasn't used back, but no, it moved, of course, the question, sorry. What is missing in spec what you are providing?
So in some way, I mean, we're just providing the configuration to it, right? Like, it can already do the thing that you want it to do, right? But it's just tricky to get the configuration right. And so what we're really doing is we're just sort of constraining the configuration options for people, right, to make it look like what they've already expecting at Sandia, and then just and then making assumptions based on that, so that they don't have to know all this configuration stuff. It's sort of like already in the template, right? Does that make sense?
That makes sense. Increasing the usability. Yes, we are a fan of that.
It's basically trying to remove some of the barriers to entry, because I mean, I think Joe and I can both attest to the fact that when we learned how to use SPAC, it was kind of a long process for us being like, wait, what do you do to get it to do this? And what do you do to get it to do this? And what do you do to get it to do that? So part of the goal of this tool is to kind of abstract away some of those complexities and make it easier, so that all you have to, you know, if you just want to use SPAC to get something that looks similar to what you're used to using before, but not have to actually learn it, then all you have to do is modify this one single file that's basically just a list, and then boom, the tool does the rest of it for you.
Okay. Sounds great. I know there's a last question. Can you make it short?
It's very short, just really quick. Okay. Joe. So on one hand, the tool that you've been working on is of tremendous value to teams at Sandia, but you're also hoping to produce something of value to the broader community, ultimately making it obsolete, getting these features into SPAC and so on. So like, how do you see like your responsibility as an RSE, both to your own institution, but also to others?
So I mean, I guess the motivation for expanding it, I mean, it started as a thing for Sandia, right? But I think that this kind of module setup with these sort of combinatoric installs of TPLs underneath it is generally useful. So I mean, that's kind of the hope, right? I guess I don't really know what you're asking there, but I feel like
you see that as sort of your responsibility, as something that you have a chance to give back, right?
If it's useful for us, and there's people who do similar things to us, maybe it's useful for them, and it really, you know, if it's going to be, if we feel like it's useful for folks who are using SPAC in a similar way to us, then it ought to be out there, because SPAC is out there, and so.
Cool.
So, thank you very much. Yeah, thank you very much to all the 4 speakers again. It's great talk. Really enjoyed it. So that was part of the official sessions.